All right, continuing our lesson, number 5. These are going to get a little more challenging only with the factoring, but we can do it together. So step 1 is to factor this. So the numerator is a 2-step diamond. So I'm going to go the first number times the last number. The middle number is -1, so those two numbers are -2 and 1. But then I got to divide. You could actually even divide in the diamond. So I'm going to divide by 2. So I'm going to divide both by 2, and that's what's going to give me my numbers. So 1 is going to be x minus 1, because -2 divided by 2 is 1. The other is 1/2, so I take the denominator and I slide it in front. And now the denominator is a 1-step diamond, so two numbers that multiply to -12 and add to -1. And then we can start filling it in. So the x-intercepts are the zeros of the numerator. So the 0 here is +1. The 0 here, go back a step, and it's the opposite number, so it's -1/2. The vertical asymptote are the zeros of the denominator, so that's x equals 4 and x equals -3, the opposite numbers. The horizontal comes from the power term on top and the power term on the bottom. So the term with the biggest exponent and the term with the biggest exponent, you divide them and they cross out and you're left with 2. That's the horizontal. There is no hole here because nothing crosses out. The domain comes from the denominator or the vertical asymptote, so the two restrictions are 4 and -3. And we'll talk about the range and 2 going with the horizontal. So let's put this on, then we might put on more things after to complete the graph. Let me find my pen. Here it is. All right, so we'll start with the x-intercepts. So that's 1, there it is, and -1/2, kind of in the middle there. We have asymptotes at 4 and -3. So I'm going to count 4 to the right and put a line at 4, and 3 to the left, and then put a line at 3. We also have a horizontal one at 2. So start in the middle, go 2 up. Now, a few things I'm going to add here that's not over here. So one thing I'm going to add is the y-intercept. So to find the y-intercept, you plug in 0 for x. Now, the easy way to find the y-intercept is when you plug in 0, the last number is what's left. And here, the last number is what's left. So if I calculate, that's +1/12, which isn't a big number, right? But I do know it's positive, it's above, and that gives me the picture here of the middle of the graph, where the ends go to the asymptote. So there's the picture in the middle, using that y-intercept. But I also have a picture on the right and a picture on the left. So the asymptote on the right is 4, so I'm going to plug in 5 and see what answer I get, and then put that in on the graph. So if I plug in 5 into the numerator, I get 5 take away 1, which is 4. 2 times 5 plus 1, that's 11. 5 take away 4, which is 1. And then 5 plus 3, which is 8. So if I put this together, I get 44/8, which is hard to put on the graph. But 8 goes into 44 5 times, and then what's left is 4/8, or 1/2. So I can put that on the graph. So at 5, I'm going to 5.5. So 5 goes 1, 2, 3, 4, 5.5. And now I have a point to curve through. I'm going to do the same thing to the left. So to the left, I have an asymptote at -3. So I'm going to pick a point to the left of -3. So I'm going to start with -4. I'm going to do the same work. So -4 take away 1, that's -5. 2 times -4 is -8, plus 1 is -7. what are we doing again? Negative 4. Negative 4 take away 4 is negative 8. And negative 4 plus 3 is negative 1. So I'm going to put this together. That's a positive answer, 35 over 8. So 8 goes into 35 4 times with 3 left over. So it's close to 4 and a half. So I'm going to go here and I'm going to go to 4 and a half. So now I know this part of the graph. So now I have a point here, and here. If you look carefully, you see how you feel trying to do this graph because it was complicated. Do you see this sad face? So there's your soul looking back at you in terms of how you feel. No. Isn't it fun to try to do something new? Something that's a little bit more layered. Anyways, last part is to do the end behavior. So the end behavior as x approaches infinity, f at x approaches, it's going to approach the horizontal, the k value, which is 2 for both. So the left end and the right end approach 2. All right, let's look at number 6. We have 4 more here for this lesson. So step 1 is having the skill to factor. Do that here. So to factor the numerator, you factor out x squared, and you're left with x plus 3. The bottom is a one-step diamond, and the two numbers are 3 and negative 1. I recognize that, first of all, I'm going to write down the domain restriction right now. So the zeros on the bottom are negative 3 and positive 1. So that's good before I cross anything out. So I do cross out x plus 3, and then I'm left with x squared over x minus 1. So everything else is going to come from here. What I crossed out is x plus 3. If you make it equal to 0 or find the 0, there's a hole at negative 3 then of what you crossed out. Then that answer gets plugged back into this equation. So negative 3 squared and negative 3 take away 1. And then I solve it. So that answer is about just a little bit smaller than negative 2. So negative 2 1/4, and that will go on my graph. The x-intercept comes from the numerator. It's 0. I want you to know it has an even exponent. So just like what I did for polynomials, an even exponent means it's going to touch at 0 and not cross over. The vertical asymptote from the denominator, the 0 there, the opposite number, positive 1. I want you to notice that the numerator is 1 bigger than the denominator, so there's no horizontal asymptote. And the range, we're not going to look at that either right now. So let's put on the graph what we have. So I have an x-intercept at 0, and it touches there. I have one asymptote at 1, and I have a hole at negative 3 and negative 2 and something. And I don't have a horizontal asymptote. So what am I going to do? So here's the answer. This is going to have a, so part of the curve I already know. So like this curve here, I know it just touches. So I already have a sense of what's happening. With these 2 points, it's going to touch and come down towards, and then the top part. I have to show you something that's really the next unit in terms of understanding. And so the next unit, there are asymptotes that are called oblique. They're slanted. And to find that part of the graph, I need to divide. So what I'm going to do is I'm going to take the denominator, and I'm going to take the 0, and I'm going to do synthetic division. I have 1x squared, 0, and if we can do another 0 if we want to. But this is the remainder. So I'm going to drop down to 1. I'm going to go 1 times 1 is 1 and add. Now the remainder actually has no effect in terms of the asymptote. So this line, this is 1x and that's 1. So it's 1x plus 1. That's called the oblique asymptote. So to graph a line, start with the y-intercept, which is at 1. And then I go up 1 over 1. So here's 1, and I go up 1 over 1. And I'm going to draw a slanted line that's broken. Now this is going to guide the picture. So now if you look at the hole and it touches there, you can kind of see the picture that gets formed there. We still need another picture up here. So a number to the right of 1, if I plug in 2 into here, so that's 2 squared, which is 4. And then 2 take away 1 is 1. So that's 2 and 4. So I'm going to go 2 to the right and 4 up. Put down a point. So this is going to go up forever, and this is going to follow the asymptote. These curves always follow the nearest asymptote, the arrows. That is a preview of the next lesson on obliques. So for this lesson, this is an outlier that we're doing. So don't get too stressed out by this. And I'm not even going to do the end behavior. The right end is up, left end's down. Everything's a little different for number 6. So I'm going to let that go and go to number 7. But that's what it looks like. Number 7 is aligned to this lesson. So we're going to factor. X minus 6 is prime. I'm going to factor out a 6. And then I want you to notice I'm going to write down the domain right now. The two numbers x can't be are 0 and 6. Then they cross out and leave you with 1 over x. So everything else is going to come from there. So because I crossed out x minus 6, make it equal to 0 and solve it, we add 6. The whole has an x coordinate of 6, and then if I plug it into here, the y coordinate is 1 over 6. If you look at the numerator, nothing makes it 0, so we don't have an x-intercept. The denominator, 0 is the vertical asymptote. That's what makes it undefined. Notice the top has a degree smaller than the bottom, so the bottom is more powerful. So that means the horizontal asymptote is at 0. And that's what y can equal. So let's put this on what we have. So I have x equals 0. I'm going to need to add some points to it, but I will. So we have x equals 0 and y equals 0. And we do have a hole at 6 and 1/6. See if I... So like somewhere around there, 6 and 1/6, we have a hole. So let's add some things to it. So first of all, it's going to look like this. I'll use the hole to curve through. I need a point on this side, so I'll pick an easy point to the left. So if I plug in -1, 1 divided by -1 gives me -1. So I'm going to go to 1, -1, -1, and I'm going to draw the rest of the curve. So I have a curve on one side and a curve on the other side. Really, it actually goes through here. So if I was like way more accurate, I would recognize with that point that it doesn't actually, these are symmetric, right, with a hole in it. So it's probably more accurate to say it looks like that than this part here. The end behavior goes to 0. All right, 2 more. Step 1 is to factor. Both are one-step diamonds, so that's 7 and -4. The bottom is 7 and 5. So I write down the domain. Look at the denominator. It's -7 and -5. Cross these out. So x plus 7, make it equal to 0. Subtract 7. So we have a hole at -7. Plug that back into here, and I get -7 take away 4. I get -7 plus 5. So that gives me -11 over -2, which is like 5.5. A negative divided by a negative is positive. So that tells me where the hole is. What's left here after you cross out is this, x minus 4 over x plus 5. So if I look at the numerator, the 0 is positive 4. If I look at the denominator, the 0 is -5. And if I take the power term divided by the power term, they have the same degree, and divide x divided by x, you get the horizontal asymptote at 1. So we're going to graph this. We can also write here that y, that's a restriction, that asymptote for y. All right, so we have a x-intercept at 4. We have an asymptote at -5, which is on the other side. We have a horizontal at 1. So I'm going to add, oh, and we have a hole at -7 and 5.5. So -7. So using that hole, I can draw this part of the curve. And then using this point, I'm going to find the y-intercept. If I plug in 0 for x, I'm left with -4/5. So that's like close to -1. So I'm going to draw the curve over here and go through the y-intercept and the x-intercept and use the hole to curve, and now I have the graph. The end behavior is the y horizontal asymptote, so that's at 1 is the end behavior for both the left and the right end behavior. All right, last one, number 9. Step 1 is to factor it. This is really a puzzle, right, that we're putting together. So some will be frustrated with the puzzle and some will like the layers to it. I like the layers to it. I find it interesting. So a simple diamond, one step, the two numbers are -5 and 1. That multiply to -5 and add to -4. Factor out of 2. Recognize these cross out. So right away I know the domain can't equal -1. So x plus 1 crossed out. The 0 there is -1. That's the whole. Then what's left here is x minus 5/2. So I'm going to put -1 in here. Subtract 5 divided by 2. So -1 take away 5 is -6. Divide by 2 is -3. That's the whole. We have a 0, the opposite number in the numerator, that's +5. We have no vertical asymptote and no horizontal asymptote. So, and the y value of the whole is the restriction for y. This is going to be a line with a hole in it. So we have -1, -3. And we have x-intercept at 5. And then we draw a line, hop over the hole, go through the line. And so we have a line with a hole in it. If I wrote down the end behavior here, we'd say the right, there's no horizontal asymptote. So the right end goes up and the left end goes down. All right, so that's the lesson on rational equations. There's a lot of layers, and whether there's asymptotes and holes and curves and points and intercepts, it's going to take practice to put the whole puzzle together. So the next video is on the homework to practice that, and hopefully some of the homework questions you try them first. Mr. G Math, over and out. Until next time.